Imagine this. A student studies for an exam for 3 months. The same student sits in an exam hall and writes the exam for 2 hours. Same student, same subject. Two completely different jobs. One job is called training, the other is called inference. Mix them up and you will be lost in every AI conversation you are in. Stick with me for a few minutes and you will know the difference between inference and training and the different types of each with simple examples. Let's get into it. Imagine you walk into your favorite restaurant. You order a pizza. 10 minutes later, the food arrives. Now here's the question. Did the chef learn to bake the pizza after you place the order? Of course not. The chef practiced the recipe hundreds of times, learned new techniques, experimented with ingredients. That long learning journey happened before you entered the restaurant. Artificial intelligence works exactly the same way. Training is the learning phase. The AI studies huge amounts of data and finds patterns. It adjusts millions and even billions of internal parameters until it gets better and better. Inference is the using phase, the learning is over. Now the model simply applies what it already knows to answer a new question. Training builds the brain, inference uses the brain. That is the biggest difference. There just isn't one way to train a model. There are four main types of training: supervised learning, unsupervised learning, reinforcement learning, and self-supervised learning. Let's break them down. Supervised learning. Imagine a teacher showing you flashcards. You see hundreds of them. Eventually, you learn the pattern. That's supervised learning. The data comes with labeled answers. Unsupervised learning. Here there are no labels, no teacher. Imagine a supermarket with customers shopping. Nobody tells the AI which customers are similar. The AI studies buying habits and automatically groups shoppers. That's unsupervised learning. Nobody tells AI what is what. The AI has to discover patterns by itself. Reinforcement learning. This is learning by trial and error. Now think of training a dog. Good behavior, treat. Bad behavior, no treat. Over time, the dog learns what gets rewarded. That's reinforcement learning. The model takes an action, gets a reward or a penalty, and adjusts. Reinforcement learning techniques help robots and autonomous systems improve over time. Self-supervised learning. This is the secret behind modern generative AI. For example, take the sentence. AI has to fill in the blank. The AI model has read text from books and the internet. It tries to guess the missing word, which is Paris. If it guessed Mumbai, it realizes that makes no sense. By playing this guessing game over and over, the AI learns how the world works. That's self-supervised learning. The data creates its own labels. No human tagging is needed. Once model is trained, it is ready for inference. That is, to actually deliver. But inference also happens in four different ways: batch, real-time, streaming, and edge. Batch inference. Imagine a bank checking every transaction from yesterday for suspicious activities. Millions of records processed together. Nobody needs an instant answer. This is batch inference. Large volumes processed at scheduled times. Real-time inference. Now imagine unlocking your phone with your face. You don't want to wait for 5 minutes. You expect an answer immediately. Face recognized, phone unlocked. That's real-time inference. One input comes in, one input goes out instantly. Streaming inference. Another great example is Google Maps. As you are driving, it constantly analyzes your location, traffic, accidents, and road closures. The AI is making decisions continuously, not just once. That's streaming inference. Streaming inference keeps processing a continuous flow of data as it arrives. Edge inference. Imagine you are traveling in Japan. You point your phone's camera at a restaurant menu. Almost instantly, the Japanese text changes into English right on your screen. For many phones, that translation happens directly on your device. Your phone isn't sending every image to a distant data center and waiting for a response. The AI model is running inside your phone. This is called edge inference. Edge inference does the work right where you are on your device. So let's recap. Number one, training is where AI learns. Inference is where AI uses what it has learned. Number two, Training can take weeks. Inference often takes milliseconds. Number 3. Training usually happens once or whenever the model is updated. Inference happens every single time you use AI. So remember, no matter whether you are chatting with ChatGPT, creating images, or translating a language, you are using inference, not training. Here's this week's small byte book pick. Now, if you want to go deeper into this, how modern AI systems are actually trained, fine tuned, and deployed in the real world, I recommend a book called AI Engineering by Chip Huyn. It's one of the most practical, founder and builder friendly books on how AI systems really work in production, from training to inference to cost optimization. I have dropped the details and link in the description box below. Before we wrap up, let me quickly introduce myself. Hi, I am Unmesh Nadkarni. I'm a tech entrepreneur, AI explorer, and builder who loves breaking down complex ideas into simple, practical insights. Through this channel, AI in Small Bytes, my goal is simple: to help founders, professionals, and builders understand big AI concepts in small, easy bites. In our next video, we'll explore another fascinating AI concept in a simple and practical way. But in the meantime, have a great one.